Hello, today's lesson is on angles of elevation and depression. We have to define them and then do some quick examples, and then you can get right on to your homework. So let's go ahead and define angle of elevation and angle of depression. So the angle of elevation is defined as the angle that goes up from a horizontal line of sight to view a desired object. So let's write that down. So angle of elevation is the angle up from a horizontal line of sight to view a desired object. And the angle of depression is the angle down from a horizontal line of sight. So I kind of think about it like if you were just looking straight and you're kind of in an elevated mood, sometimes people think that you look up. So that might be elevated mood, looking up. Okay. And then if you're depressed, sometimes maybe you look down. So, depression down. So, for instance, in this picture here, we have a woman standing on the grass field looking up to a hot air balloon. So here is this pink line right here is her regular horizontal line of sight, but she has to look up 38 degrees to see the hot air balloon. Therefore, that is an angle of elevation. If somebody is in the hot air balloon, their regular line of sight, horizontal line of sight, looks like this, but then to look down to the woman, they have to look down 38 degrees. Okay, so let's talk about how we describe these angles. So here's a situation where we have a mountain, a hiker, and a cabin, and we have 4 different angles. So let's go through and describe them. So angle 1. Angle 1 has a vertex at the mountaintop. Here is the horizontal line of sight for the mountain, if the mountain could look out. And angle 1 goes down from there. So angle 1 is the angle of depression. If you hear my dog, I'm sorry. He just jumped on my lap and he's got a little bone on him, chewing on a bone. So sorry about the background noise. So angle 1, the angle of depression from the mountaintop to the hiker. Phil, go somewhere else. Okay, angle 2 is starting at the hiker, has a vertex at the hiker. Here's the hiker's horizontal line of sight, and angle 2 goes up from there. So angle 2 is the angle of elevation from the hiker to the mountain. Angle 3, we also have a vertex at the hiker, but angle 3 goes down, and now we're looking at the cabin. So angle 3 is the angle of depression because it goes down from the hiker to the cabin. And angle 4 has a vertex at the cabin, and the cabin's line of sight is right here, and angle 4 goes up from there, so that's my angle of elevation from the vertex, which is the cabin, to what it's looking at, the hiker. All right, we have 2 more examples. So, define the height of Delicate Arch in Arches National Park in Utah. A surveyor levels a theodolite with the bottom of the arch. From there, she measures the angle of elevation to the top of the arch. She then measures the distance from where she stands to a point directly under the arch, and her results are shown in this diagram. What is the height of the arch? Okay, so here, if I was to redraw this triangle, here's what's going on here. Let's redraw it so it's flat, because it's kind of a 3-dimensional picture, so it looks like it's at a wonky angle. We have a right triangle, we have X, and we have 48 degrees. But they also talk about this little 5 feet here. So this, we have a little 5 feet, and we're looking for this entire height here. So that's really what we want. So if we find x, all we have to do is add 5 to our answer. And the other measure they have is this right here, 36 degrees. So I have a right triangle, which means I can use my trigonometric functions. So let's see here. My angle of interest is 48 degrees. And with that being my angle of interest, x is the opposite side and 36 is the adjacent side. So sine, opposite over hypotenuse, nope, can't use that. Cosine, adjacent over hypotenuse, nope, can't use that. Tangent, yes, tangent is opposite over adjacent. So for this one, I say the tangent of 48 degrees equals opposite x over adjacent 36. And I don't know why I put that degree symbol on that 36. Let me erase that. Okay, so tangent of 48 degrees equals x over 36. Multiply both sides by 36 to get the value of x. Plug that into my handy dandy calculator. And we get that the height, we get that x is approximately 39.98. Okay, or about 40 feet. But remember, we have to add 5 to it. So the height of the arch is about 45 feet. Okay, our next example does not have an accompanying picture. And it's a little complicated. So let's go through. To approach a runway at Poncha City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from an altitude of 2,700 feet. The airport altitude is 1,007 feet. How many miles from the runway is the airplane at the start of its approach? All right, so let's draw ourselves a little picture here. We got a plane. Sorry, my plane is not very good. Here is the plane's horizontal line of sight. And I'm going to do a 3-degree descent. So if it does 3-degree descent, then I'm going to get to the runway. Okay, here's my runway. And we know that here is sea level. And when we are at sea level, the plane is 2,714 feet from sea level, and the runway is 1,007 feet above sea level. That's what altitude means. It means distance above sea level. So if I just look at this triangle here, I have a right triangle, and I can figure out the length of the short leg. So the length of this leg right here is 2,714 minus 1,007, which is 1,707. And if I just look at that blue triangle, that's the triangle I am interested in, okay? So let's see here. So we have this, we have a right angle here, we have 3 degrees here, 1,707, and it asks us for the distance from the airplane to the runway. So it's asking us for that direct distance or the hypotenuse of that triangle. So 1,707 is the opposite side, and x is the hypotenuse. When the angle with 3 degrees is my angle of interest. So I'm going to use my sine ratio. So sine of 3 degrees equals opposite over hypotenuse, so 1,707 over x. Get rid of that fraction, multiply both sides by the denominator. So I get x times sine of 3 degrees equals 1,707. Divide both sides by sine of 3 degrees. And I get x is approximately 32,616.2 feet. But if I look up here, the question did ask how many miles. Ooh, I like that pin. That's a cool pin. So if I think about how many miles that is, I know there are 5,280 feet in a mile. So I'm going to divide my answer by 5,280 feet, and I'm going to get 6.18 miles. Okay, so angles of elevation and depression. I think the hardest part is that these mostly are going to be word problems, and setting them up can be tricky. Try your best on the homework, and we will go over it next time. Thank you.